Right. So second part of lecture 16, rational function, for we're going to look at how to find horizontal asymptotes. Again, in this case, you have a rational function of the form p of x over q of x, for p and q are polynomial functions, and you don't want it not to be equal to 0. So the horizontal asymptote horizontal asymptotes. Oh, yes, yes. All right, so maybe one. Okay. Anybody else? Part two. You all good? Part two. All right. So horizontal asymptote described the end behavior of rational functions. So when you talk about the end behavior, that means you want to know the value of the function, the value of y as x approaches negative infinity. So usually when you find horizontal asymptote, you want to answer that what is the y value as x approaches negative infinity or positive infinity. All right. So you have a couple of situations here to determine the horizontal asymptotes of irrational functions. So in this case, as x approaches positive infinity, the y value approaching b. Okay. So as x approaches positive infinity, y approaches b. You with me? In the second case, as x approaches negative infinity, y approaches b. You with me? Okay, so that's the end behavior of the rational function. So y approaches b as x approaches positive infinity. And here y approaches b as x approaches negative infinity. So if one of this case occurred, then you conclude that y equal to b is a horizontal asymptote. So let me explain this notation a little bit before I give you the notes. So x approaches negative infinity. All right, so these notations indicate that x approaches negative infinity. This notation means that x approaches positive infinity. And y arrow B, that means y approaches B. Or the output approaches the value. Okay. So there are two notes that I want to give you. When you look at the graph of the function, a rational function, or any function for that matter, and when you want to analyze the vertical asymptote and the horizontal asymptote, you can see the behavior of the graph will behave a little bit different. So here, when you look at the horizontal asymptote, the curve can actually cross the horizontal asymptote. However, when you go back to the previous lecture, when you talk about vertical asymptote, you can see that the graph cannot cross or touch the vertical asymptote at all. Okay, so that's the two things to review that. For vertical asymptote, the graph of the function cannot cross or touch the vertical asymptote, but the graph can cross or touch the horizontal asymptote. So the first note, the graph of f cannot cross or touch vertical asymptote. Here the graph of f can in fact cross touch a horizontal asymptote. So for the first note, why can't the graph cross or touch the vertical? Why can't it? Is there a reason why the graph of f cannot cross or touch the vertical? We make the observation. So this two statement are true. But why that is? Why we have that? Is there a reason? There you go. Oh, because remember how to find vertical asymptote. What most of the time, whatever value that you exclude from the domain, that's going to be vertical asymptote. And because you exclude from the domain, therefore the graph cannot cross the function, cannot cross it. Got it? All right. So let's move on to the next part. So in this part, we're going to find the horizontal asymptote. This is the technique to identify the horizontal asymptote. All right. So in this case, I want to write down a little bit of detail of P of X and Q of X. Again, what I have here is a rational function. Rational function is a fraction P over Q for P and Q are polynomial functions. Okay. Now for the numerator, this is what we have. Be careful. I need something when I write down the details here. So this is the polynomial functions of degree n. And in the denominator, you have polynomial functions of degree m. You're okay with that? It matters that that you be able to notice the power n, the power n. We need that later. So here, this is, I need the new computer, man. It's flicker a lot of times lately. So the numerator is polynomial of degree n. And in the denominator, you have polynomial of degree m. You okay with this? You know where is n coming from? Which is the highest power of the polynomial. Do you know where m coming from? Again, the highest power. Now, there are three cases that you need to consider when you have the value of n and m. When n is less, if n is less than m, when n is less than m. So I'm very specific here. N is the degree on the numerator. N is the degree in the denominator. If n is less than m, the horizontal asymptote is always y equal to 0. Always, no matter what. If n is less than m, you have the horizontal asymptote to be always y equal to 0. Now, in this example, you see that on the numerator, polynomial is of degree 3, and in the denominator, the polynomial is of degree 5. Okay, so this is degree 3 over degree 5. Right, so 3 less than 5. So therefore, you conclude that the horizontal asymptote is y equal to 0. So put this answer in some context. Don't just give me 0. Say something like this. Horizontal asymptote is y equal to 0. Okay, because you say x equal to 0, that's going to be wrong. In this case, y equal to 0 is a horizontal asymptote. The next case, if n equal to m, the horizontal asymptote is going to be y equal to a sub n divided by b sub m. So this is the horizontal asymptote is the ratio of the leading coefficients. So again, I'm very specific with the notations here. The polynomial on the numerator is of degree n, so therefore the leading coefficient is a sub n. In the denominator, the polynomial is of degree m, so the leading coefficient is b sub m. Now, if the degree are equal to one another, then the horizontal asymptote is going to be the ratio of the leading coefficients, a sub n over b sub m. You okay with that? Okay. So now let's consider the second example. I have this rational function. The degree on the numerator is 2. The degree in the denominator is also 2. So therefore, the horizontal asymptote is y equal to 8 over 4. You with me on that? Okay. So here, the numerator is of degree 2 over degree 2. So therefore, you say that the horizontal asymptote is y equal to 8 over 4. Again, this is the ratio of the leading coefficients. This is equal to 2. And for the last case, any questions? Now, for the last case, when you have n greater than m, you can automatically conclude that there's no horizontal asymptote. There's, in fact, an A asymptote is called the slant asymptote, but we're not going to cover that in this case. I just want to mention that to you so that if you want to explore that topic by yourself, you can do so. So, slant asymptote. And it can be found using long division. So if you want to explore long division, you can do so. All right. So example 3 here, on the numerator, it is the polynomial of degree 4. And in the denominator, it is a polynomial of degree 3. So you can conclude that there is no horizontal asymptote. So basically, that's it for horizontal asymptote. That's it for rational function. There's many topics related or many concepts related to rational function, but we already covered that, including vertical asymptote, horizontal asymptote, and also rational. Now, at this point, we kind of going to combine all the topics together into one big problem related to rational functions. All right, so example 4, 5, and 6 related to finding the horizontal asymptote of the function. So this is a multiple choice. It's very easy to put this on to a quiz or a test. So example 4, the horizontal asymptote of the function is, so what is the answer? Look at the degree of polynomial on the numerator. So y equals 0. So here, degree of polynomial on the numerator is 1. Degree in the denominator is 2, so 1 less than 2. So we say that the horizontal asymptote is y equals 0. What about example 5? What is the answer? C. C. Right. All right. So again, in this case, the degree on the numerator is equal to the degree in the denominator. So the horizontal asymptote is equal to the ratio of the leading coefficients. So 32 over 8 would be 4. So y equals 4 is the horizontal asymptote. And number 6 is going to be none. Excuse me. Any questions? This 3 example. Good. One more thing I want to mention, you have seen this one many times already, but in rational function, you can actually find x and y intercept as well. So x-intercept y equal to 0, and then you solve for x. For y-intercept, for y-intercept, you have x equal to 0, and then you solve for y. So in finding y-intercept is easier than finding the x-intercept in the case of rational function. You will see that in a minute. It's a little bit tricky, but this is supposed to be. All right. In the next example, we know we're going to include a lot of topic related to rational function in one place. Consider this rational function of the form x plus 2 over x minus 3. The first thing we need to do is find the domain of the rational functions. So the domain is that of x different from 3. Because we're not going to remove or cancel any factors, so there's not going to be the 4 on the graph function at all. So this value that you exclude from the domain is going to be the vertical asymptote. So you say that vertical asymptote is x equal to 3. All right, I'm gonna skip C for now. I'm gonna go back. I'm going to go back after D and E because we kind of on the topic of finding the horizontal asymptote. So let's do that first. So for horizontal asymptote, you look at the function again, look at the degree of polynomial functions on the numerator and the denominator. And you see that they are equal to one another. So therefore, the horizontal asymptote is y equal to 1 over 1 equal to 1. I'm gonna go do a GoFundMe campaign for new laptops if you want to contribute. The school gonna give me a new one, but take probably a few months to get this process. Anyway, do you know where I got this number of 1 and 1? Yes. Not the power of it. All right. So remember, when the power is equal to the power equal, right? Then is the horizontal asymptote going to be the ratio of leading coefficients. So the one that we see is actually 1 times x. Okay. Then here it's 1 times x as well. You remain that. Okay. So the ones that you see is here. So 1 times x, 1 times x. Yeah. So this is the one. This one are the leading coefficients. So now E finding x and y intercepts. So for me do x-intercept first. So for x-intercept, you set y equal to 0. That is, you set the function x plus 2 over x minus 3 equal to 0. So this is the tricky part that I mentioned a little bit earlier, that when you set the irrational function equal to 0 and you solve for x, you just need to set the numerator equal to 0. You just need to solve the numerator. Because when you find the domain of the function, you already exclude x minus 3, or you already exclude x equal to 3. So the only thing that we need to carry is the numerator. You okay with that? Good, good. So the x-intercept is -2 times 0. Now for the y-intercept, You set x equal to 0 and you solve for y. So this one is a little bit easier. You get y equal to 0 plus 2 divided by 0 minus 3. You have the answer to be negative 2/3. Then you conclude that y-intercept is 0 comma negative 2/3. What time do we go? 20 or 15? 20. Okay. Yeah. All right. Are you okay with A, B, D, and E? Any questions on those? All right, let me go back to C. Now I want to study the behavior of the function near the vertical asymptote. So we did this problem, similar problem, but when we have the graph of the ratio, that is a lot easier. It's a little bit harder to analyze without the graph, but bear with me. Let me go back to the previous lecture. So for the vertical asymptote, right, you want to know the behavior of the function near the asymptote. And if you notice the y value either approaches positive infinity or negative infinity only. Right? So the behavior of the curve near the asymptote, only positive infinity or negative infinity. You're okay with that fact first. Okay. Now, when you analyze that, you need to see x, you analyze the function when x approaches the vertical asymptote from the right, and the vertical x approaches the vertical asymptote. You with me on that? Now go back to our problem. The vertical asymptote is x equal to 3. All right, so what is happening to y, or to the functions, as x approaches 3 from the left and as x approaches 3 from the right? Good? Yeah. So as x approaches 3 from the left, you have f of x here. As x approaches 3 from the right, what happened to f of x? Bear with me here. So the function we got is f of x equal to x plus 2 over x minus 3. Okay. You don't need to give me the exact value. Doesn't have to be. You just need to give me the sign when you analyze this type of problem. As x approaches 3 from the left, what happened to the functions? Okay. Now, as x approaches 3 from the left, so this is 3, approaches 3 from the left. On the left of 3, what do you get? This can be 2, this can be 2.9, this can be 2.99, can be 2.99. You know, the closer to 3, the better. But as we see earlier, the function f of x either approach positive infinity or negative infinity only. Okay. So as x approaches 3 from the left, what is the sign of the numerator? Is that positive or negative? Positive. You with me on that? Because on the left of 3, 2.9, 2.99, 2.999. Right. So on the left of 3, as x approaches 3 from the left, the numerator is positive. What about the denominator? Is that going to be positive or negative? On the left of 3. Negative. You okay with this? You with me? Right. You know where it's positive coming from. You know where it's negative coming from. All right, so positive over negative gonna give you negative. Therefore, as x approaches 3 from the left, the function is going to approach negative infinity. So here, the numerator is positive, the denominator is negative, and therefore the function is approaching negative infinity. Now, as x approaches 3 from the right, you have f of x. Right. So approaches 3 from the right of 3 can be 3.1 or can be 3.01, can be 3.0000001. Now, on the approaches x approaches 3 from the right, what is the sign of the numerator? Is that positive or negative? Positive. Now, for the denominator positive or negative? Positive or negative? On the right of 3, so that is greater than 3. It's positive. Let's just try, let's see, 3.0001 minus 3 is positive. Right. So positive over positive give you positive 8. So in this case, you have positive over positive. So therefore, as x approaches 3 from the right, the function is approaches positive infinity. All right, so let me show you the graph of the function real quick before we go. So x plus 2, the all right. So as x equals to 3 right here, right? As x approaches 3 from the left, function is approaches negative infinity, right? And as x approaches 3 from the right, the function approaches positive infinity, right? Which match with our analysis. And also the horizontal asymptote in this case, positive 1. There is the imaginary line, like the y1, which is the horizontal asymptote. All right, so that's it for me. Thank you for being here, everyone. I will see you tomorrow. Have a good day. So in example 8, all of these questions kind of very similar to example 7. That is given a rational function, you have 2x minus 1 over x plus 3. You want to find the domain of the functions, identify the vertical asymptote. We're gonna study the behavior of function near the asymptote, right? So we did that toward the end of yesterday. It's a little bit difficult than all the questions. So we're going to spend a little bit of this again. D, identify horizontal asymptote, and at the end, find the x and y intercept of the rational functions. All right. So again, this is rational function. This is a fraction. You don't want the denominator to be 0. So the domain of the function is that of x different from -3. And I mentioned that a few times that there are different ways that you can present the domain of the functions. Either you can write this in practice, it's very straightforward, x different from -3. But for a mathematical term, you can write this in the interval notations as -infinity to -3, union with -3 to positive infinity. Or you can write this as all real number except the element -3. All right, so there's a few different ways that you can tackle this. So that is the domain of the functions. Now, the next question is to identify vertical asymptote, right? The function is already in a factor form, did not make any cancellations, so therefore, whatever value you exclude from the domain, that is going to be the vertical asymptote. So here, the vertical asymptote is x equal to -3. Any questions? Now in C, we're going to study the behavior of the function near the asymptote. Remember, when you do this kind of study, the answer usually just negative infinity or positive infinity. Okay. But it's a little bit, I understand that's a little bit difficult to analyze this without graph. So bear with me here again as I could write things on the board. So the function we got is f of x equal to 2x plus 1 or 2x minus 1 over x plus 3. Okay. So you have vertical asymptote is x equal to -3. So there are two situations that you need to follow. That as x approaches -3 from the left, what happened to the functions? Okay. And as x approaches -3 from the right, what happened to the function? Okay. And when you do this kind of problem, you don't need to calculate the exact value. You just need to look at the sign of the numerator and the sign of the denominator. Right? It's tell you a lot of information already. So here you have -3. Now, as x approaches 3, -3 from the left. So -3 from the left, it can be negative 3.01, negative 3.001. So with that in mind, as x approaches -3 from the left, what happened to the numerator? Are you going to get positive number or negative number? Negative, right? Because whatever negative number you substitute here, negative minus another negative is going to be negative. Right, so the numerator is always going to be negative. Happy reunion. Yeah, it's been a while. How's it going with you? Huh? How's it going? Okay. All right. So now with negative x approaches -3 from the left, what happened to the denominator? Is that negative or positive? On the left of -3. You want what? Negative. Negative. Do you see that? You don't see that? Questions? You okay with the numerator to be negative? You okay with that? You okay with the denominator now that negative? Yes. Okay. So negative over negative become positive. So as x approaches -3 from the left, the function approaches positive infinity. So that's the first part. So as x approaches -3 from the left, f of x is equal to, so on the numerator is negative, on the denominator is also negative. So you have the functions approaches positive infinity. Now we follow the same analysis, but in the case when x approaches -3 from the right, right? So -3 from the right. On the right of -3, you have negative 2.99, 2.999, so on and so forth. Right, you substitute that into the numerator. What do you got? Do you have negative number or positive number? What do you got? you have x approaches -3 from the right. Okay. That is on the right of -3, such as -2.99, -2.999, things like that. You put that into the numerator. What sign do you have? Positive or negative on the numerator? Negative. Okay. What about the denominator? Negative or positive? Positive. Right. So it's positive in this case. So therefore, as x approaches -3 from the right, the function approaches negative. You have the numerator is negative, denominator is positive, so the function approach negative infinity. You good? You follow? Any questions?
Yeah, I just have a quick question.
Yes.
If you put a substitute, a positive.
What?
Like, if like there's like a positive number.
This one?
Yeah,
You talking about this functions or in general?
yeah, just general, or actually this function.
So you study the behavior of the function near the asymptote.
Yeah.
So that's why we consider around -3.
Yeah.
Right. So because you consider this around -3, the numerator always give you negative.
Yeah.
In this context, for this function.
Yeah.
Right. But if you look at the problem from yesterday, right, so numerator, because the vertical asymptote is 3, so you're talking about some number around 3. Therefore, the numerator. Did I answer?
Okay, yeah, I think that's pretty solid.
All right, so let me go to D, identify horizontal asymptote. Do you need functions? So to identify horizontal asymptote, you look at the degree of polynomial on numerator and the denominator. So the degree on numerator is 1, and the degree in the denominator is also 1. So they are equal. So the horizontal asymptote is equal to the ratio of the leading coefficients. So y equal to, look at this, the leading coefficients here is 2, and the leading coefficients here is 1. Right. So therefore, the horizontal asymptote is, let me write this, horizontal asymptote is y equal to 2 over 1 equal to 2. Questions? Right, for E, we're going to find x and y intercepts. So for x-intercept, you set y equal to 0 and you solve for x. And the functions that we got is 2x minus 1 over x plus 3. So you set this equal to 0 and you solve for x. So 2x plus minus 1 over x plus 3 equal to 0. Right, so for this rational function, when you set this equal to 0, and you want to solve for x, you just set the numerator equal to 0 and you solve for x. Okay. Again, because you already exclude x equal to -3 from the domain, so you don't care about the denominator. Just set 2x minus 1 to 0 and you solve for x. So x in this case is equal to +1/2. Right, so x-intercept is 1/2 comma 0. And for y-intercept, you set x equal to 0 and you solve for y. So y is equal to 2 times 0 minus 1 divided by 0 plus 3. So you get -1/3. So the y-intercept is 0 comma -1/3. All right, case. All right, so let's work on example 9. We're gonna focus on part C again. Hopefully we will get it after this example. The function we got is -3x plus 4 over x plus 2. Okay. So the domain of the function is everything except -2. Or you just write x different from -2. Because you exclude -2 from the domain and also there's no cancellations. So therefore the vertical asymptote is x equal to -2. So I have mentioned this a few times. When you write the answer and put this in some context, vertical asymptote is x equal to -2. Don't just give me -2. Doesn't mean anything. Right. Now we study the behavior of the function near the asymptote. Okay, so you got the function, the vertical asymptote is -2. So you can see there are two cases. As x approaches -2 from the left, okay, be careful with the notations. And as x approaches -2 from the right, you're with me on that, right? All right, so here is -2. So on the left of -2, you can think of as a few numbers, -2.01, -2.001, things like that. All right, so negative number, right, -2.01, you put it in the numerator. Negative times -3 become positive. You with me on that? You follow? So positive number plus 4 is still positive number. So in this case, the top, the numerator is always positive. Now, what about the denominator? Is that negative or positive? Negative. Plus over minus, so therefore the functions will approach -infinity. You okay with this analysis? You understand where is the sign on the sign coming from? All right. Now let's move on to the second case. As x approaches -2 from the right, so -2 from the right can be -1.99, -1.999, but still a negative number. So you substitute here into the numerator, negative times negative become positive, plus 4. So the top still being positive, still a positive number. Okay. Now, what about the denominator? In this case, as x approaches -2 from the right, the denominator is positive or negative? Positive. You with me on that? Okay. So positive over positive. It's positive, so the function approach positive infinity. So again, there are two cases that you need to consider as x approaches -2 from the left. You have the function is that of positive on top and negative in the bottom. So therefore, the function approach negative infinity. And as x approaches -2 from the right, f of x is equal to positive on top, positive in the bottom, and the function approach positive infinity. You okay with the part C? I think most of your work, and I see that you did well on A, B, D, and E. A little bit of studying time on your own to fully cover. So D is the horizontal asymptote is y equal to, so in this case, -3/1. Equal to -3. So any questions on D should be straightforward at this point, I hope. For E, you find x and y intercepts. So for x intercept, you have y equal to 0 when you set the function -3x plus 4 over x plus 2 equal to 0. Again, in this case, you already exclude -2 from the function, so you just need to set -3x plus 4 equal to 0 and solve for x that way. So this give you 4/3. So the x-intercept is and for y-intercept, you have x equal to 0, right? So y is equal to -3 times 0 plus 4 over 0 plus 2, 4 over 2, this is equal to 2. So the y-intercept is 0,2. Yes. Good. Tired. Skylar, yes. Yeah, me too. For the last 2 days, I just woke up in the middle of the night. Sleep until like 5 in the morning. Very tired right now. Actually, everyone's very blurred. Okay, we have one more page to cover. Spend a little bit of time on the last page of this problem. So all of this question hopefully is are doable for you. Okay, just take a little bit of time to see what you got. So these are multiple choice questions. You don't have to show your work, but be careful with your with the choices. So I hope you, yes. All right, so number one, what do you think going to be the answer? What one? B. All right, yes, B, yes. All right, so if you factor the numerator and denominator, you exclude the two values, A2 and pi B2. Those are the vertical asymptotes test cancellations. So 1B, yes. What about 2? What is the horizontal asymptote in this case? C, you have y equal to -5. You want to agree with that answer? Remember how to find the or determine the horizontal asymptote. You look at the depends on the degree of polynomial on the numerator. So let's identify the degree first. The degree of the denominator is easy to see, it's 2, 2, but the numerator is a little bit hard to see. So what I'm going to do is that I'm going to expand, combine, multiply it out for the numerator and see what I get. What type of polynomial function I get. So on the numerator, I get x squared plus 5x minus x minus 5. So the numerator is x squared plus 4x minus 5 over x squared minus 4. So the degree on the numerator is 2. The degree of polynomial in the denominator is also 2. So the horizontal asymptote is equal to the ratio of the. So 1 over 1. Therefore, the answer is. So 2b. Good. Now for 3. A. Right. So the vertical asymptote is x equal to 9, x equal to -8. All right, number 4. What is the horizontal asymptote here? C. Right, so y equal to 0. Right, why that is the case? Because the degree of polynomial on the numerator is 1, and degree of the polynomial in the denominator is 2. So therefore, you have 1 is less than 2, or is always y is 0. And number 5. A. Okay, good. Any questions? Good. All right. So that's it for lecture 16. So the exam on Monday, I still need to make up the practice exam, but hopefully it can be done by then. So the exam going to cover all the materials from lecture 10 to lecture 16 up to this point. Okay. Again, the practice exam will consist of 2 false questions, multiple choice questions, and written responses you will see in the practice exam.